In this video, we will not talk about how to draw shapes, but instead we'll talk about how to use functions to organize and restructure our code for better maintenance and reusability. So I already have some letter forms that I've drawn in P5, and hopefully there's nothing you don't know about these functions like beginShape, endShape, vertex, etc. If anything is unclear, I encourage you to check my previous videos or maybe watch some coding training videos for a few basic tutorials on P5. And I will leave this drawing code down in the description, but I think it'll be best if you come up with your own design because then you will be able to face your own problems, which is a good thing. So let me explain just a little bit about my code here. So I have lowercase c shape here with beginShape, endShape, and a few different vertices. I just plot them out individually. And I also indicated that it's 100 pixel width, and that will become useful later on. And then next I have lowercase e shape, so I'm gonna comment out C and uncomment E. It's basically have the same structure, beginShape, endShape with a few more vertices. And then lastly I have F, which is a little different because F is made up of two different strokes with the addition of this crossbar. So that is handled as a just simple line function. And another thing to note here is that every letter here is drawn from the top left corner, which is origin 0, 0. So right now, if I uncomment all these drawing codes, it looks kind of awkward. But drawing from the origin is pretty useful because it makes it easier to move things around when everything starts from 0, 0. And depending on your design, it might be better to set this origin or 0, 0, not at the top left corner, but maybe at the baseline of lowercase letter, just like how most typefaces are designed from. So now looking at this, our code is already getting pretty long, right? We only have 3 letters we've drawn, but it's already 44 lines long. And what if I write a whole sentence or make a poster with tens of different letters? Then you can guess we'll end up with hundreds of lines of code, which is really not necessary. There's got to be a way we can simplify and modularize and makes it easy to maintain our code. So that's where a function comes in. And for now, we'll use functions to group related instructions together. So here's what I'm going to do. I'm going to move out of the draw function, and at the bottom of my sketch, I'm going to make my own function called drawE. And all the codes related to drawing E shape will be placed inside of this function instead of having all of these in the main draw loop. Same with other letters. I only have 3, so I'm going to make a 3 function. Oops, I should have started with C. It doesn't really matter, but let me just organize myself a little better. So C, E, and F. And you can imagine if you had more letters, then you can have more functions like this and organize them accordingly. So all I'm going to do, there's nothing really changing. I'm just going to cut this whole thing out and paste it into drawC function. I'm going to do the same for E and F. Now my whole screen is empty now. We only see the background color. That's because this function, drawC, drawE, and drawF, are function definitions. So this is basically a recipe for drawing different letters, but I haven't used them yet. So if I want to use this code inside each function, then I'm going to have to call that function. Just like how we would call, no fill or stroke weight, we can also create our own function and call them. So if I say drawC and call it, then you will see this appears here. Same with E function or F function. So there's not really anything changed in terms of our drawing or compositions, but our code became much simpler. If you just look at the draw function where everything happens, it's very easy to read and understand and see what's going on. And you can even repeat and use it multiple times. even though we won't see any difference because two different C's are drawn on top of each other right now, but we'll fix that later. But my point here is that function here becomes a reusable modular block. And if you make a new sketch, then you should still be able to copy and paste the same code, same function definitions, and start using it. And once we are done with this drawing process, then we don't have to worry about how it's drawn, how many vertices are being used. We just simply call these functions, and that's how we use it. And because I want these functions to be reusable, I'm trying to make my function, what's inside this whole content, as general or generic as possible. And that's one of the reasons why I drew them all from the same origin point. It makes the calculation a lot easier. There are a few different things we can do to make our functions more flexible and adaptable, which is by adding function parameters. Just like stroke function. Let's take a look at stroke function, which is given to us by p5. And we can type in different number to change the color of our stroke. So stroke isn't just adding a stroke, but we have a lot of different options based on what parameter we give to it. We can even go all full color, right? Just like that. We can also add these parameters to the functions that we make. So how about we start with stroke weight? Right now, stroke weight is set here, but I want to move this inside of my function. So let's say if I say draw C10, then my C shape will be drawn with 10 pixels of stroke weight. Then if I call maybe draw E, then E shape should be drawn with 20 pixels of stroke weight, and so on and so forth. So I want to handle them all from within my functions. Right now, if I pass in this value, my function definition doesn't know how to handle it, because as you can see, my function definition doesn't have any like a variable attached to it. So if I pass this value, my function needs to be able to receive it. And that's easy. You just give it a name. Just like how we create our own variable, we can sort of create a variable that will only be used inside this function, and you come up with your own name. So in this case, I'm trying to control stroke weight, so I'll just call it SW. And you don't need any like a variable type here, just put the name. And then in the function, I will call stroke weight here, not outside and not in the draw function, but call the stroke weight inside my function definition, and my stroke weight function will take that value. And it will also try to pass this value down into my function. So now SW is storing a value of 10. And this value stored in SW can be used in my function definition. So if this is your first time using your own function, it may sound a bit confusing, but hopefully with some practice, you'll get used to it. And again, you should definitely watch some other YouTube tutorials from Coding Train. That will be immensely helpful. And now, if I change this parameter, the first parameter of draw C, to something else, as you can see, it updates its own stroke weight. So this is working. And what about other function? Can I call draw E with stroke weight? You can, because this parameter only works in draw C function. So if you want to replicate that, you need to repeat this for all the other functions. So I'm going to do that. And also update my draw F function as well. And of course, whenever you add something new, make sure you test it. So draw E looks like it's working. Let me try another value. Looks great. What about draw F? Works fine. Works fine. Great. What other things can we add to this function? What other parameters will be useful to make my functions reusable for many different situations? I think one of the most obvious one is to be able to set its position, right? Instead of always drawing from the origin, maybe what if I want to draw it somewhere at the bottom right corner, for instance. And that can also be handled through a few additional parameters. So at least this is what I want to do. So when I call, say, draw F function, I want to control its X and Y position. as well as my stroke weight. By the way, the number of parameters and the order of the parameters, that's all up to you. We just have to be consistent. The way we use it and the way we define should all match. But other than that, it's really up to you what parameter you want to add, how you want to use it. You should definitely experiment with it. So X and Y. I'm going to add X and Y. So it can take 3 different parameters. So if I call draw F with, say, 300, 300, and 2, what I'm expecting it to do is F shape will be drawn at the bottom right corner around here. So I'm going to add that X and Y to all my 3 function definitions. And really it doesn't do anything because we are passing these 3 parameters, 300 for X and 300 for Y and 2 for SW, stroke weight. But we are not using X and Y anywhere in our code. Then what can we do? How can we move this? There are a few different ways. You can give an offset. So every time I'm drawing something, I will add to its X coordinate. So it's moving by X pixel, right? Every time I'm drawing something, I'm adding that much. And same with Y. So now my F shape is drawn at 300 by 300 because we've drawn from the top left corner. It's probably somewhere here. And you can move it around, place it anywhere you want. And stroke weight should also work. 20, it works. 150 by 150, around the center. So that's great. This function is now much more flexible. But one problem that I see here is that these X's and Y's that I have to add every time I draw something. So I have to do this all over again here. I think it'll be much better if there's a way we can sort of group the whole shape and then move them all at the same time. So let me undo or just delete all these X's and Y's from my drawing functions. And we'll try something different and just explain this concept. Let me switch to my Illustrator file. So here I have a design. So what I'm trying to do is instead of moving one point, add X much, Y much, and another point, X much, Y much, something like that, which is really tedious process. Rather, I want to just handle them all at the same time. Just like in Illustrator, I can just grab it and move it somewhere, right? But to handle with the code, if I want to move, or in this case, I will say more proper term, translate. If I want to translate my whole shape, I cannot do that. Instead, I have to move my entire coordinate system. So that's what we call matrix transformation. So imagine there's a like translucent, like plastic sheet that this F is drawn on. So I'm gonna just draw a shape, let's say, which looks like this. And my F is drawn on top of this like translucent piece of paper. So if I want to move this F somewhere else, then what I'm going to do, I'm going to grab the whole paper and just move it somewhere else. So that's how it works. Of course, you can move individual points or draw something else on the same piece of paper by just plotting them out one at a time, like 50-50, 20-80, or something like that. But if you want to handle multiple things together all at the same time, and this is how you want to do, by moving the entire like a piece of paper or entire coordinate system. But if I do that, it might also affect all the other shape that's drawn on the same piece of paper. But what I want to do is just to isolate this whole transformation. So there are a few different functions, commands that we can use in P5. So let me switch back to my editor. And here is how I'm going to do. So we are still drawing F. So let's take this as an example. So all these drawing code, which are using these coordinates, it is referring to my whole canvas coordinate, right? 20 and 150, this one at the bottom. But like I said, I want to add like a translucent, invisible piece of paper and draw F on it instead of drawing on the entire canvas. And that action of adding another piece of paper is called push. So if you push, basically we are adding another set, or you can think of it like a layer, although it might not be exactly the same idea. But if it helps, I think that's okay. So I'm gonna add this push, so adding one more, like a layer, and everything that's drawn after that, after you push, will be drawn on that separate sheet of paper. But after we use it, we have to remove it once we are done with it. Otherwise, it will keep adding and adding and adding, and eventually your program will crash. So that action of removing the extra sheet is called pop. We'll pop it out. So push and pop always works as a pair. Just like beginShape and endShape always work together, push and pop always work together as well. So all the join code or all the codes that's using these coordinates will be drawn at a new piece of layer or paper, however you want to call it. And then I'm going to move that separate sheet of paper to somewhere else on my screen. And we use translate function. And that translate function will be also in between push and pop, but before you use those coordinates. So it's typical, you have push, and right after we have translate, and then we have all the join codes, and then pop it out. Okay? And then in translate, we give how much you want to translate or move the whole thing, whole piece of paper, by giving X and Y offsets. So right now, because I didn't do anything, it's starting from 0, 0. So there's a whole canvas and there's invisible extra sheet of paper, but they are all using the same top left corner as the origin. So if I move maybe 100 by 100, my F will be drawn around here. So let's try that. 100 and 100. There you go. You can try different values like that. So I didn't have to touch anything from my original drawing code. I can keep them as they are, but I can still be able to control and move my whole letter form by using push and pop and translate. So now, one last thing left to do is, instead of just using 100 or any other numbers, we will connect to X and Y. So whatever X and Y value we pass down from function call when we actually use it, these values, 150, 150, will be passed down to X and Y, and those values, 150, 150, will be used to translate. So with this structure in mind, I'm going to also update my two other functions. So I'm done with updating my function definitions, and let me go to draw loop and do some testing. So I can call draw C at probably 40, 60 with 10 pixels of stroke weight. And I know draw C is 100 pixel width, so I can draw E right next to it by adding 100 to the X coordinate. 140, 60. Why not try different stroke weight this time? 20. There you go. And I'm going to draw F right next to it. So E is also 100 pixels wide. So adding 100 will be 240. And keep the same Y coordinates and same 20 pixel. Just like that. So our code became much more simpler. If you just look at the draw function, it's very easy to understand what's going on. And all the drawings are hidden inside each function definition. And of course, you will need to remember what these numbers are for and how they are set in what order. Because sometimes when you just say X, Y, or SW, it might not be very clear. So in that case, you can definitely add some comments for yourself. So there was quite a lot that I covered in this video. Again, I'll leave some other links, some useful links for you to learn more about this whole transformation thing, which is really wonderful once you get to understand it. And I've only barely scratched the surface of it. So definitely check them out. And my question here is that what other parameters will you add to your own design? So my X and Y and stroke weight was just an example. but what other things you want to add. Some other numbers, some other strings, because the parameters are basically what sets the range of the expression. So I highly encourage you to continue with this function definition and adding more code, even bringing more join function just to practice. And I'll see you in the next video.